I'm still David Price. How many people are familiar with ASTM 1465? You got 3, 4? Yeah, you don't. I'm sorry?
Not by number, maybe.
Okay, the mitigation new construction standards for new construction, ASTM. Okay, how about Appendix F? Okay, we got one that knows Appendix F too. Okay. All right, so this group needs to learn a bit about putting radon systems in new houses. You guys obviously know a lot about radon mitigation, so putting systems in houses is not that tough. Because you guys know all that you need to know, except some of the details that'll make it easier for you. And a lot of the things that you have to do, because I've done a few mitigations myself, the black holes that you have to track down when you're doing a mitigation of an existing house, you can avoid all that stuff when you're building a new house because you can hopefully do it right and maximize the efficacy of your systems. So that's what this slide kind of gets to, is make it easy to fix. If there's a problem, if we've got a test, make sure you can get a fan in there easily. Do things that'll prevent radon entry, and you know what those are, but they're easier to do in new construction. Or just install the whole system, an active system to start with. But these are things you're going to have to work out with the builder. I'm not going to go over the health stuff because you all know that story. These two slides only point to the fact that there's some current work by the World Health Organization talking about what's the risk of radon. And basically the conclusion is that there is no safe level. You all know what the story is. We work to 4 Pikey Curies because that's what the technology allows us to get houses below when we're doing mitigations. But the lower you can get those levels, the further you're reducing the risk. So in new construction, you can do that just by paying attention to making a good gravel layer, making sure the slab's sealed, all those kinds of things that you know about, but we'll go over some of those again. The zones, you know what those are. And please raise your hand if you don't know something that I'm skipping over here, okay? That's the United States. All right, here are the standards we're going to work with. I should amend that. We're not going to work with all of them. We're going to work with 2 of them, basically. The first one is the International Building Code, the very first one there, Appendix F. Let me find my button. There you go. The second one is ASTM International 146508, and that is the standard for putting radon-resistant new construction features in houses. 2 documents are quite different. You're going to find that out. One's like, I think, 38 pages. That's this one. 38 pages. Tiny type. Appendix F, if you're ever in the building code, that's tiny type too. But that's only 7 pages. So you can kind of see the disparity there in depth. The National Fire Protection Association has a standard as well. And EPA has a guidance book that we put out years ago called Building Radon Out. The only reason I put it up there, it's not a standard, but it is a wonderful reference document for you to get a hold of. So you can go online and get it. Sorry, I didn't mean to take that off. You can go online and get it, and I would advise you to do that. And lastly, it's something I had to put up there even though it's very old. It's the document that me and one of my counterparts developed at EPA years ago in '94, and it's basically the work that these other standards were based upon, and these are our model standards for new construction in homes. It's another good document to get off our website. That's the model standards I just spoke of. Here's kind of the derivation of these things. From those model standards, we had a CABO standard in 1995, BOCA, SBCCI, and ICBO. All those codes, as you know, were merged into the ICC and then became the IRC. Let's talk for a minute about 1465. This is the thicker of the 2 documents. The pipe route for the passive system is built and it's efficient. The passive system will get you reductions up to 50%. Not every time. That's kind of the average, what we're seeing. The initial test result, if they're not acceptable, you have to add a fan. So pretty simple, pretty straightforward. The other option is to pipe the system with a fan-powered system. The pipe routing is different when you choose this option in 1465. You have a little bit more leeway in how you can run the pipe because it's designed to have a fan on the end of it. As you know, with passive systems, it's in that first option. Oops, I'll get this in a minute. In this first option, it really relies on the fact that the pipe in the passive system is internal to the house, and you're relying on the heat of the house to provide buoyancy to pull that radon gas up the pipe and out of the house. With the second, with the fan-powered system, you've got a fan that's helping you, so you can be a little bit more free with how you run the pipe. And you know, you got to negotiate with this with the builder, but for my dollar, I would probably try to push him in that direction because I've worked with subcontractors enough over the years. I used to be a general contractor myself, and you don't know what people want to do with your pipe. When you're putting in a mitigation system, you know where the pipe's going. You're designing it for your pipe. When a house is being built, you do a stub up out of the slab, and then you try to get people to do what you want them to do, but sometimes you come back and it's not where you wanted it to be. So if you've got a fan that's pulled on the pipe, you can work around a lot of problems. So anyway, that's just one way of looking at it. ASTM 1465. Here's a key issue between the difference between 1465 and Appendix X of the International Building Code. Acceptable radon level is negotiated between the builder and the buyer or the client. If there is no client, if it's not a custom home, then they're going to the builder's got to make a choice on his own, or his or her own, what they want to do. Acceptable radon test results are required. If the first tests are not acceptable, you've got to fix, and then you test again. So 1465 is pretty stringent about that. In Appendix F of the IRC, there is no testing requirement, but you got testing in this cycle with the 1465. Radon labels. There are 5 radon different labeling points in the radon systems in 1465. I'll go over the pipe itself. There's the membrane's labeled. The system itself is labeled. The sump cover is labeled. And then there's some information on a radon service provider that's provided as well.
Is this just the agenda because it's going pretty fast?
Okay.
Are you going to be going over all those points?
Yeah, I'll go over them again. And everything up here, make sure we have all your names, and I'll send you my presentation with all these slides, okay?
A quick question, that 50% figure, passive system reduction.
Yep.
Is that tested and verified, or was that just like a best guess kind of thing?
No, I've got a slide at the very end. Remind me, I'll show it to you. NHB did a study and collected a whole bunch of data for us. I'm sorry, I didn't repeat the question. He wanted to know how veracious that number is, 50% reduction. And my answer was that NHB did a study for us, and I have a slide to that, and we'll talk about it a little bit later. Just the outline of the system, pretty simple. You've got, starting down here, you've got a gravel base layer. One of the things, I'm going to maybe go over things more than once because, like I said, my slide sequence is not what I want it to be. One of the things you'd want to do here in new construction is, when you're doing mitigation, you're kind of often, you put a T-fitting after you've opened up the slab. In new construction, you're better off if you can run about 10 or 20 feet of perforated pipe to either side off this T. You're going to get better suction off that entire slab. Or a loop of pipe tied to this T, which really enhances the ability of you to draw on that slab. Life's good, right, compared to fixing an existing house. Polyethylene soil gas retarder. The sealing and caulking, this is critical, especially if you're going to be putting in a passive system and you're getting only the benefit of the buoyancy of the heat in the house to move gases up the pipe. You don't want to have air being pulled from the house in this floor wall joint where the slab meets the foundation wall of the house. It's really critical that that be caulked properly, and you didn't, if you fell down the job. You were supposed to hold this up when I said that. You know what this little item is? It's an edger. When you go out on a job site and the guy's finishing the slab, hand him this if he doesn't have one and ask him to pull an edge around the slab. it makes it so easy to put a good caulk joint around that edge. The other way is, this is really kind of neat stuff. This is a product that's used as an expansion joint. Lots of people like to use an expansion joint. But check this out. The top, after the slab's cured, pulls off. There's your half-inch bead. Have anybody seen this before? It's great. Used in commercial jobs a lot. Okay, and so we have the vent pipe, and then finally we've got electrical receptacles here. One for a gauge or alarm, and one up in the attic. Now, the building code requires what in an attic, as far as electrical is concerned? Has to have a light. Got to have a light in the attic. So the electrician is already running electricity to the attic. Yeah. So it's a simple phone call to the electrician, or write it on the plans, or mark it up in the attic once it's framed, put a receptacle, and you tell them where you want it. You know where you want to put the fan, so make it easy on yourself. Okay, estimated cost of passive systems. Again, the 50% number. It says here, this is a slide I borrowed from someone else's presentation. It's still a pretty good number, $390. Adding a fan, another $300. Here's some numbers I did 2 years ago. I just sat down one night and started figuring up stuff just to see what my number would be. And I figured it was a 2,800 square foot home, 44 by 32 is the footprint that I just used. I'm figuring a 35 foot, which is, code height on maximum most houses. So I figured up my vent stack of 4-inch Schedule 40 pipe. I did not include a labor figure here. That's important to remember. Flashing boot on the roof, a sump basin. Your standard sump basin, your crock, plastic crock, is about $20. You buy it at Home Depot. You go to the plumbing supplier where I buy my stuff, and you can get one with a gasketed cover, a nice one, for $36. So there's an additional cost there. Polyurethane caulk to do the 168 linear feet. I figured 10 tubes of that. Receptacle box. I said electrician, he'll probably put a box in for me for another $20. 6 mil poly, so I had $272 in that. So I'm less than that, what was it, 380 figure on the other slide. And then I figured some areas like around the country you can't get washed gravel, or maybe they're not using it for some reason. If you had to truck in gravel for that, where I am in Annapolis, Maryland, this is kind of what we'd pay for 4 inches of gravel to cover that space. So we're up to $737 if we've got to put gravel in. But that's kind of the exception around the country. Most areas of the country, they're putting gravel under slabs. Code requires it. That's a reference document I mentioned earlier, building right on out. I would highly recommend you get a copy of it. Okay, here's the comparison. The gentleman in the back to the right with the baseball hat on said, are you going to go over this again? All right, let's go over it again. 1465, 38 pages versus Appendix F, 7 pages. 1465, you have the choice of a passive or an active system, if you're following that. And Appendix F just calls for the passive system. The builder and the buyer negotiate acceptable radon levels here in 1465. Here's a huge difference. In Appendix F, there is no testing required. You're just putting in a passive system, and we hope for the best. System performance testing. Less than 4 picocuries before occupancy. You got to have it below 4 or you can't get an occupancy permit. With Appendix F, there is no testing. If it's greater than 4, the fan's required by the builder to lower the levels. And over here in Appendix F, you have to build it to be fan ready and alarm ready. In other words, you have to have the receptacle boxes in both locations, but you don't have to put a fan in. Okay, or 1465, you get a radon test and you have to have the documentation. The builder has to provide the results to the homeowner. No testing again with Appendix F. 1465, basement or slab on grade, sub-slab depressurization with a vent stack. Over here, same, okay? Crawl spaces are a little different. Submembrane depressurization in 1465 with a vent stack, and sub-slab depressurization, meaning you can pour a concrete rat slab. Everybody know what a rat slab is? Over top of the polyethylene. You have two options there. In the Appendix F, you can do the submembrane stuff, but they also allow mechanical ventilation of the crawl space with no vent stack. Now, someone tell me what issues that may raise if you... Say again, please?
Tremendous amount of moisture coming in.
Where's it coming in from?
Outdoor air comes in, hits the cool down below, and condenses out.
Okay.
Cold air in the winter.
Cold air in the winter. How about radon? How much? Now we're not testing. Remember over here, we're not testing. Okay, we're ventilating the crawl space over here, but we're not testing. So we don't know what the radon levels are either, do we? In the back there, green shirt.
One of the biggest problems is in the mechanical world, ventilation is exhaust, and you're going to make the radon level higher.
Right. Depending on how you build that crawl space, you can be depressurized in the crawl space and actually pulling in some radon into that crawl space. Yes, sir.
Our problem can compete with all your clothes in this thing.
Yeah.
At foundation vents and half the time.
Right.
90% of the time.
Well, there's a kind of an interesting little anomaly here in this. What Appendix F allows you to do, which I think is problematic, is it allows you to put mechanical equipment in the crawl space. You can ventilate it like this, but you can also put equipment in, and what the requirement is that the equipment has to be sealed. So, and it includes the ductwork, has to be sealed. Have you ever tried to seal ductwork and get it really, really tight? It's hard to do. And cabinets, the air handler cabinets are really hard to get tight because first off, if you start running caulk all around them, you void the warranty with some manufacturers. You just can't take your RCD mastic and paint the whole cabinet and make it airtight. So if I was involved in that, I'd be building myself a conditioned crawl space if the builder was doing it, and I would put in sealed combustion furnaces using outside air for the combustion. So it allows you to do it, but I think let's remember what we're trying to do here. You're trying to provide a service to a builder, and in my mind, if I'm the builder, I want it turnkey. I don't want to get a phone call when little Johnny goes to, his sixth grade class and comes home with a radon test kit, and then my house ends up having high radon levels. I want the system to work. So I would be advising the builder against doing that. We can do a lot better by using a vent stack and a membrane in the crawl space. Here with 1465, we have the membrane laps. Membranes are lapped and they're sealed. They're glued or they're taped. And also when it comes to the crawl spaces, they have to be glued and affixed to the wall. You have to use a ramset gun or something to use some furring strips and get it tight to the wall and make it stay there. Over here in Appendix F, you don't have to do that. You just lay the poly down and lap it. You don't have to seal it. A few more things. I already went over that. Air handling equipment. Okay. Tight ductwork if you do it with Appendix F. There's another kind of interesting thing. Ducts in the soil, not allowed under 1465. Well, we all know why we don't want to do that, right? Why? You mine radon. You get a leaky duct, like radon leaks into the duct work, and there you go. In Appendix F, they allow it if the ducts are sealed and the system is positively pressurized. Now, does that mean you have to run the system 24 hours a day, or am I missing something?
Maybe the return ductwork is above the grade, and
well,
the other one is
it doesn't really matter. If it's not running and you have leaks, it'll permeate the system. So I don't see that that's much of a very good option. Yes, sir.
Could they mean that supply ducts can be in a slab but not return ducts?
It doesn't say. It doesn't say. But we found when we were doing some of our early research 15 to 18 years ago that we were getting radon in the houses through supply ducts. We had a builder in, where the heck was that? Minnesota. Very well-known builder whose name I won't mention. They were putting radon systems in the house. They were stubbing up pipe under the slab, and then they were running all the supply ducts under the slab. So wait a second, guy, what are you thinking here? But anyway, okay, this is just a little part of the discussion I always bring in because I hate pouring concrete. I have the worst moments of my life have been pouring concrete. This is where these guys live, and I hate this place. This is a slide to show you another fear that I have in my life. I should be in therapy. I am in therapy. This is the actual day they're pouring this slab at a school over in Maryland, and these guys are hustling to get the insulation, the 2 inches of insulation under that rebar and wire before they pour. It was supposed to have been done Friday, and it's Monday, and we're pouring, and they're not done yet. So I feel great about that because that always happened to me. And no matter how hard I worked to get everything on site ready to go, it was never ready. I just threw these in. Everybody ever seen a slump? Know what a slump test is for concrete? Okay, that's what's happening right here. They've turned it over and they're looking at the slump. These are a course. They're going to pour different truckload samples in there to make sure they're getting the proper mix. Our inspector guy knows all about that, I'm sure. I throw this slide in there because this never happens or maybe if you've got a big builder and he's pouring like 10 foundations in one day. But smaller jobs, you never have enough help. You never have teams of people helping you. There's 3 guys, and then one of your forms breaks or the truck gets stuck, and it's just a nightmare. And where I'm living, we pay 10 yards of concrete in one truck is $1,300. And the guys usually will stay on site for an hour, and then every minute after that, you start paying for it.
For an hour?
Yeah. No, that's from the plant.
Oh, okay.
From the plant. Yeah. So if you've got this team of guys, life is good, but usually that doesn't happen. Look at them; they're everywhere. All right, I put this slide in here just because this is a joint. Now you don't see this a lot in houses, but you've got an interior wall here. It'd been really nice if they'd have used this or this, so they'd have a nice clean joint to caulk here. Just trying to show that same thing. This is not a radon pit. What is that, you think? There you go. Say it loud so the camera guy can hear it.
Sewage injection.
Sewage injection pump. Okay. But the same rules apply that we have to use on some covers. We've got to seal around this edge so we don't have leaks here. And then these are nicely gasketed. They're kind of filthy, but then you want to use this thing again to get a nice edge around the perimeter of this cover. Have anybody seen the Formadrain product? Anybody use that? It's a certainteed product. Instead of building wood forms or digging your footings in the soil, you put this stuff up, and it has the drainage capacity right built in. This is the drain tile. Okay. The thing I would caution you about, I mean, it's a great product. Who has an opinion on connecting outside drains and inside drains, foundation drains? Yes, sir, in the back. Yes, in the green shirt? Never?
Never.
Okay, so that's one of the messages you got to tell your builder and talk to your code guy. Do you agree with that?
I actually should be a fouled up guy. I agree with it.
Yeah. So they're kind of good at this of telling you how you can connect everything, and this is a one-stop shopping, and you can connect everything to this. Nah, don't do it. Okay. Keep your radon system, and your foundation drainage system, your foundation drainage system. More pictures of lots of people working. Let's see, 2 inches of sand, wire mesh. That's just showing the lap of the polyethylene. We're doing on time. Doing pretty good. All right. These are just some of the things to stay away from when you're putting slabs in houses. How many people hear builders whining about concrete and membranes? They like to punch holes in the membrane so it cures. Yeah, who else hears that?
They do it.
Yeah, oh, they do it. They definitely do it. Yeah. It's a bunch of malarkey, okay? So you need to talk to the builder about that, and I can send you information from American Concrete Institute and from the Portland Cement Association. I've talked to all their engineers. A couple things you can do. They're saying, well, if we don't put holes in the membrane, then the slab's gonna curl. Well, first off, they're not curing the slab properly. They're supposed to cover the slab with burlap or something so it doesn't lose all the moisture from the top side. It's going to dry faster on the top than it does in the bottom. But why don't they cover it? Time and materials, too much trouble. The finisher has to stay there another hour or two to trowel it one more time, or just wait till he can trowel it. It's going to take longer. The other thing the experts tell you is you don't see slab curl in houses. The slabs are too small. Okay? It's almost like an old wives' tale. When you're pouring a warehouse concrete slab and you've got control joints everywhere and you're covering something that you can build automobiles in, it's a plant for, GM or something, you see slab curl. And it's an issue because you're going to be driving forklifts on it and that kind of thing. In houses, they're tiny. You don't get slab curl in these small slabs.